Hello, I'm Edward Tarte, math teacher. In this video, I'm going to give you my solution to my math challenge video, Battle of the Cookie Armies. Here is the way I presented that challenge. This is about a battle between two armies of cookies, the gingerbread army and the chocolate chip cookie army. Those two armies advance toward each other, each in a solid square formation of rows and columns. But the gingerbread army outnumbered the chocolate chip cookie army by 2,048 soldiers. Nevertheless, the smaller chocolate chip cookie army fought so bravely that they destroyed half of their opponents while losing fewer than 600 of their own, thus reducing both armies to exactly the same size. At the beginning of hostilities, how many were in the gingerbread army and how many were in the chocolate chip army? Here's my solution. I'm going to have G stand for the number of gingerbread cookies on one side of their square, and C stand for the number of chocolate chip cookies on one side of their smaller square. And so we have this equation, G squared minus C squared equals 2,048. I have factored the left side of this. We call it the difference of two squares. Its factors are G plus C times G minus C. And factoring the left side suggests let us also factor the right side, this 2,048. It's a rather special number. Its prime factors are all 2's. We divide by 2 over and over and over until we get to this 2 on top. There are 11 2's involved there. Indeed, 2,048 is 2 to the 11th power. All those 2's make it relatively easy for us to list factors of 2,048 in pairs, starting with 2,048 times 1, and we just double the 1, 2, 4, 8, 16, 32 as we cut the larger factor in half each time. And so we have these pairs of factors. And so we have G plus C times G minus C can equal any of these pairs of factors. And that suggests setting the larger G plus C equal to the larger factor and the smaller G minus C equal to the smaller factor, and try to get some possible solutions out of that. So I do that one pair at a time. My first pair is G plus C times G minus C equals 2,048 times 1. Setting G plus C equal to 2,048, G minus C equal to 1, I can solve this system by adding the two equations because the plus C and the minus C add up to 0. It gives me 2G equals the odd number 2,049. That's no good because G then equals 1,024 and a half, and we don't want any halves. We can't have it. So this is a dead end. But the other factors, once we get past this 2,048 times 1, the other factors do generate possible solutions. So our next one is G plus C times G minus C equals 1,024 times 2. G plus C equals 1,024. G minus C equals 2. I add the two equations. 2G equals 1,026. I divide by 2, G equals 513. I substitute that value into either of these. It gives me C equals 511. And indeed, we have here two square formations. 513 squared, that's a lot of cookies, minus 511 squared, that's also a lot of cookies. The two armies differ by 2048. This is a possible solution to the problem. I'm going to call it the first candidate solution. But there are other candidate solutions, again, based on what you see here. Our next one is G plus C equals 512, G minus C equals 4. That leads to another pair of square numbers that differ by 2048. This is our second candidate solution. Here is our next candidate solution based on G plus C equals 256, G minus C equals 8, giving another pair of square numbers that differ by 2048. We have two more candidate solutions. This one, G plus C equals 128, G minus C equals 16, giving these square numbers that differ by 2048. And finally, G plus C equals 64, G minus C equals 32, giving these two square numbers that differ by 2048. Those are what I call candidate solutions. Now our task is to try to narrow it down to just one correct solution. And to do that, we refer back to what I said in the problem. The smaller army of chocolate chip cookies reduced both armies to the same size by destroying half of the opposition while losing fewer than 600 of its own. The only one of the candidate solutions which satisfies that is this one. Losing half of 5184 would be about 25 to 2600. Losing fewer than 600 of its own could reduce both armies to the same size. That condition makes no sense whatsoever with the other candidate solutions, but it does make sense with this one, and so this one is our one correct solution. The gingerbread army was a 72 by 72 square containing 5,184 soldiers. The chocolate chip army at the beginning of hostilities was a 56 by 56 square containing 3,136 soldiers, a difference of 2,048. So that's my solution to the chocolate chip and gingerbread army cookies challenge. Thank you for watching this video.